Welcome to the next tutorial, and the story so far we're talking about resultants and about using methods, analytical mathematical methods of finding out what resultants are. So we had this horrendous tale about these three brothers just arguing with each other, pulling this poor donkey. And we found out that the resultant force of all them pulling the donkey is going to be 577.13 newtons, 12 degrees in this direction, in that direction. So what I want to have a chat to about now is this concept of equilibrants. Now what an equilibriant is something that takes the force system back to a sum of all forces equals zero. So it sets this back to zero. So that means that when we add all the forces together, that they equal each other out and equal zero. So an example of that would be, once again, if we had a look at our people here, and they're going to be, tug-of-warring against one another, like so. And we're going to have some blue people over here, and we've got these guys working in this direction, and they've got 1,000 newtons worth of force pulling, and these guys in this direction have got 1,000 newtons pulling in this direction. So you don't need to be a genius to see that those forces are going to equal each other out. So we'd have negative 1,000 newtons plus positive 1,000 newtons equals no newtons, equals no force. So we can say the sum of all forces, that means the sum here, equals zero, because they equal each other out. So in this tragic tale with the brothers who are having major family issues, need some family counselling, if we find out what the resultant force is, which is here, this is the resultant force, we can also determine what the resultant force is. So let's say, for instance, that this donkey is not moving. Okay, the donkey's stuck in place. No matter how hard they pull this poor little donkey, he's not moving. So he's going to be exhibiting a equilibriant force for that not to move. And it's the exact opposite to the resultant force. So we could write that equilibriant equals 577.13 newtons, but working in that opposite direction, still at 12 degrees. So the only thing that's changed here, sorry, I've made a bit of a mess of this arrow, so I'll draw it in again. The only thing that's changed is the sense. What's the sense? Well, we've spoken about that before. That's in a vector. That's the sense. So the only thing that's happened is the sense, and that will bring this force back to this force system back to zero. Similar to the way that it's done it here with this force. So I have another problem. So let me sort of digress. If you're asked to find the equilibriant force, you would just do that. You just show the force going in the opposite direction. If you wanted to do the resultant, then obviously that's going to be the resultant there. So they're very similar. Essentially, one is the resultant of those forces, addition together, and one is equaling them out. So they have a sum of all forces equals zero. I'm going to finish this tutorial there, just so I've explained the concepts of equilibriants, and we're going on to the next video after this, where we're going to go a little bit further with that concept.